Hello, Assalamu alaikum, good morning. Myself, Dr. Mohammad Siddiqui from the Chemistry Department, King Fahd, University of Petroleum and Mineral, Dhahran, Saudi Arabia. At the outset, I would like to thank Dr. Amtul for inviting me and providing the opportunity to share my work at the International Industrial Chemistry Conference being organized by the NED. I would also like to thank Dr. Saida for facilitating and coordinating all the activities related to the conference organizations. So, as far as my work is concerned, I will share my work here, and please give me a minute. So this is my affiliation and conference. So my topic is synthesis of active carbonaceous materials from the functionalization of asphaltenes for industrial and environmental applications. What are the asphaltenes and from where they are coming actually? So this background I have to share with you. In fact, everybody knows what the fuel is, what the petrol is, but we are talking about the crude oil. Crude oil is very delicate mixture of two types of organic hydrocarbons. Ratio of lower molecular weight hydrocarbons to ratio of higher molecular weight hydrocarbons. Ratio of polar hydrocarbons to the non-polar hydrocarbons. And this ratio makes the crude oil very stable. Disturbing this ratio leads to the precipitation and instability of the crude oil. What I have studied in the last 20 years or so, that we try to precipitate by adding non-polar solvent, which is alkanes. Once we add the alkanes, the highly polar molecules present in the crude oil precipitated out, and those highly polar molecules are called asphaltene. And this work is all about the asphaltene. Initially, my work was related to only investigate the chemistry of asphaltenes, how they work, how we can crack it, how we can use it for the refining processes. But in the last 20 years or so, you might have witnessed the emergence of the nanomaterials and carbon-based nanomaterials. We have the carbon nanotubes, carbon fibers, carbon as a substrate. Looking at these possibilities or these dimensions, I thought, why not look at the asphaltene in this dimension? Nobody has done any work in the asphaltenes using as a active material, carbon materials, which can use as an adsorbent or the filler. So that prompted me to explore the possibility of using asphaltene or converting asphaltene into the active carbonaceous materials. Initially, I failed. I used asphaltene as it is. When I tried to find out its size, it was macro rather, even not micro. Forget about the nano. Then we try to modify it. Then we try to do some reactivity of the asphaltenes. And ultimately, what I did, I tried to oxidize these asphaltenes just to compare whether they can be used in place of already available carbon materials like maybe CNT or others, activated carbon. And that was the leading point, and that led to a good discovery, you may say, we got pretty good number of publications, patents, and definitely projects. So what are the asphaltenes if we need to define? It was used, I mean, as a novel. It was a novel, adsorbent. It was developed from the undesirable portion of the petroleum matrix, which is asphaltene. I'm coming down there. It has very high ratio of carbon to hydrogen atoms, elements, and it is asphaltene mostly concentrated in the high temperature residue. It's not available in low boiling point fuel or the fractions. Easily available, and it was functionalized, tested. We found it efficient. Its efficacy was pretty high. Now, so what are the asphaltenes? Actually, asphaltenes, as most of the work had been in the asphaltenes. Now it is shifted to another direction. Here consider most troublemaker part of the crude oil for refining and cracking processes. They precipitate out, and once they precipitate out, they reduce the flow of the oil. It can lead to the blockage problem, can form the silage, and if part remains, it can poison and deactivate the catalyst in refining or cracking processes. The structure of the asphaltene is very complicated and complex. We have never determined, not we, I mean, no one has ever determined the absolute structure of the asphaltene. Rather, we always use the average parameters. What could be the average parameter? What could be the average structure of asphaltenes? And based on that, we simulated, and the people have simulated and come out with that it is a possible structure for the asphaltene based on the, and these structures depends and differ based on the origin of the oil, crude oil. The composition and the structure of the asphaltene of the Saudi Arabian oil will be different from the composition and structure of the asphaltene from the other part of the world. Basically, they are the polyaromatic sheets stacked one after another, and then they have the alicyclic and aliphatic groups. They have heteroatoms as metals, mainly nickel and vanadium. They have more metals, but these are the most prominent. You must be surprised why I'm showing this slide. Cholesterol. Actually, this is a normal artery. This artery, what is showing it here, that it is the blood flowing fine, but then there's a deposition of yellow material, which is cholesterol. And those who are the health conscious, they monitor it, their cholesterol, lower and high, both cholesterol, they monitor it, and they knew it, what is the consequences of this. So ultimately, when the cholesterol keep on depositing, it forces the blood, blood comes with more force, and then it hit the heart, and then you know what happens, consequences. There's another picture, is showing the deposition of the asphaltene in artery. What is the significance? Why I'm showing this? Because this cholesterol is a part of the blood. We cannot get rid of it. And at the same time, it also deposits in our arteries. Asphaltene is the cholesterol of the crude oil. When the crude oil, it flows or transported through the pipes, it gets deposits inside the walls. And you can see sometimes it is fully blocked. Sometimes you can scrape it, and then you can see others also. So this is the asphaltene is the cholesterol of the crude oil. That was the idea, that this material, before we were studying how we can crack it so it can convert to the fuel, so it can be used for the different purposes. But now, when I take this study to the different direction, nobody has done it, and still people have not. No, I don't see literature that people are working in this field yet, though I have already published and I'm holding around 10 US patents in this field. I will share with you. So what happens here, this asphaltene, which is definitely harmful portion of the crude oil, but important portion of the crude oil because it also helps in the stability of the crude oils. When I studied the asphaltene, the structure of the asphaltene, then it comes out to be the same. These are the stacks of the polyaromatic hydrocarbons. They are the definite width, length, thickness, okay? And we use an XRD. And this is just simple, you may say the gist what these asphaltenes are from the only XRD. They are layered. And those layered, just like you can see the graphite in the pencil, one after another, these are the sheets. And they have this certain length and width and the thickness. And we use the XRD, gamma band and G band and 10 and 11 or 002 bands, and these we figure out. This is the rough model. It's not prepared by us, but it shows how the asphaltene sheets are. You can see carbon to hydrogen ratio is less. There's less hydrogen, more carbon, and it also has some heteroatoms. So what happens here, after choosing, this is the chemistry of the asphaltene. After choosing that asphaltene should be utilized for what? Because a lot of adsorbents were available in the market. People were talking about the carbon. So we thought to look at this carbon, how it can be utilized. And then we looked at it that the metals, they are very toxic, hazardous in nature, so they should be removed. They should be, adsorbed. Dyes are also very dangerous, toxic. They should also be, they contaminate the water, so they should also be removed. At the same time, I also use these asphaltene as a filler in polymers. And using this asphaltene because people use carbon and other nanomaterials to increase the strength of these polymers. And then it also afforded good results that the activities of the, you may say the mechanical strength of the polymers can be increased using these asphaltenes. We looked at it, there were several methods, several adsorbents were available, methods of precipitation, ion exchange, reverse osmosis, adsorptions and more. There are more methods are there. Then adsorption is found to be, it's very easy, simple, fast, efficient, and the material is reusable. It has effectiveness also. All adsorbents, they have the merits and demerits. I don't want to go in that detail. So activated carbon is very much used or very prevalent nowadays, is being used, but it has a high efficiency comparing with the many different solvents, but it is costly, and it is some selectivity problem and regeneration problem. Also in the literature, there are agricultural waste, there are industrial waste, and in those industrial waste, they contain some sludges, and they may contain, or they contain some hazardous materials also. Carbon nanotubes are very effective, but at the same time they are costly. And when we talk about carbon nanotubes or carbon nanofibers or carbon nanomaterials, they are costly, as well as there's still not clear protocols are available for the safety. How we are going to take care of the safety if anything happen or with these nanomaterials overall. So ultimately, in our work, what we did, we took the asphaltenes, we isolated these asphaltenes from the crude oil, high boiling fractions of the crude oil, and then we tried to functionalize it, oxidize it. As I said, initially I failed, but we used a mixture of the acids, then it gives us the good result in the sense, first we characterize it, after that it bore oxygen whitish, and that helps to absorb the metals and the dyes and the others. Chemistry is very simple. If you use dyes, there's a pi interaction or a interaction with the oxygen lower pairs. This is not the, the carbon-carbon double bond. You have the electron cloud there. They can interact. For the metals, we have these carboxylic acid at the lower pH. There will be carboxylate ion, and we have the cations, so they can interact. They interact, and they afforded us more than 95% of removal. Actually, more than 95%, sometimes 99% adsorption of the metal cations. We find out here. So due to charged surface and other activities, what it is here, use of asphaltenes or functional asphaltenes as the adsorbent, it has not been reported before. Therefore, in this study, we focus to develop adsorbent, and we have to look at the mostly adsorbent used for the metals and dyes. Okay, this is a model just trying to show you that this asphaltene, we did the functionalization using the nitric acid and H2SO4, and it develops the oxygen moieties, carbonyl groups, and others. Okay, and then when you can look at the elemental analysis, it gives initially it was 2.92% of oxygen. After functionalization is 27.83%, which is also supported by the IR. You can see the development of the IR bands at the carbonyl region that indicates that the the asphaltene, it bore now the carbonyl groups and maybe the ether linkage. And then when you use it, the dyes, there are more than 90%, 95% were adsorbed. So this is the one thing actually. You can see the adsorption here. It is when the pH is low, it helps for the adsorption of the metals. Actually, this is close to neutral, so it's good for the dyes. Okay, you can see I'm just showing the one slide here of the copper, and you can see that we use a different parameters: pH, dose, time, temperature, concentration, and percent copper, percent adsorption. You can see 99.58% of the copper metals were adsorbed in 1 hour. 99.58%. We also recycled this after regeneration. We use it, and its efficiency, effectiveness did not decrease. It was, did not decrease means it was still more than 90%. This is a general model. When we use asphaltene with the HDPE, high density polyethylene and low density polyethylene, and after using these composites, we try to find out what is there any effect in the strength of these polymers. And you see, when we compare the virgin HDPE with the composite and the LDPE with the composite, the mechanical strength property, whether it is elongation or it is the tensile, they increase much. They showed higher values than the virgin HDPE and LDPE. So the point is here that these asphaltenes have not been explored yet. I will not say yet. I was the first who used these asphaltenes, and I got so much in fascinating results that afforded me at least 10 to 12 patents, and few are in the pipeline now. So just I want to share with you that this adsorbent, asphaltene have been very effective. We isolated from the crude oil, which are highly, as I say, undesirable part of the crude oil. They provided excellent results here for metals and ions. And as a filler also, they are, good support as a filler for the enhancing the mechanical strength of the polymers. We are right now working to adsorb the harmful gases like H2S, even natural gas CH4, carbon dioxide, all those gases we are trying nowadays. And I mean, work is progressing, and we are having good results now. These are the few patents. If you look at this, I mean, from this work or this type of the work, Arabian asphaltene reinforced polystyrene, nitrated amine asphaltenes. This is polypropylene. This is again method removing of dyes, another US patent. And then we have the density, and again this is for the dyes, and again it goes for the I mean HDPE, and some of the patents are in pipeline. Well, this is a general idea. I was talking about, I did not go to detail of the technical thing because I want to give the impression that this field is highly unexplored, and I pick it up and it rewarded me in this type of the patents and the publications. So thank you all, and this is my email. If you have any question, clarification, you are most welcome to ask me anytime. Send me email. And once again, I want to thank Dr. Amtul for her invitation. Thank you. Thank you very much.